Our topic tonight is the limit definition of a definite integral. So we've already covered Riemann sum, so I just kind of want to reiterate one fact here. We have a continuous function over the interval a to b. Continuous meaning I can draw this function, there's no holes or vertical asymptotes. I can draw without picking up my pencil from a to b. And we divided this interval from a to b into subintervals of equal width. So whatever width I'd pick, it has to be the exact same. So I divided them into equal rectangles in this case. And not only rectangles, they are right-handed rectangles because I go up on the right, hit the curve, and come over. So I do want you to copy this down. Let the non-negative function y equals f of x be continuous over a to b. We divide a to b into n subintervals, and here's the key. Our width we're calling delta x. And to get that delta x, we just take b minus a, and we divide by the number of rectangles that we want. The right endpoints of the subintervals are designated x sub 1, x sub 2, x sub 3, dot, 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 x sub k, dot, 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 up to x sub n. So obviously you can keep going until you get to however many rectangles you wanted to see. Here's the next key. X sub k, so any random spot I pick, is equal to a plus k times delta x. So a is the starting point, plus k times the change in the width, where x sub n is equal to b. For each subinterval, we'll construct a rectangle shown in the diagram. So here are three key ideas. The base of the rectangle is delta x. Okay, so each of these is represented by delta x. That represents the base. And the formula for delta x is b minus a over n. This distance minus this distance divided by n. And I'm going to skip to 3. N represents the number of rectangles. 2. The height of rectangle k, so with x sub k as its right endpoint, to get the height, just like common sense should tell you, if you know x, you're going to plug it in to get y. So if I know the x value is x sub k, to get the height, I find f of x sub k. Now remember, a Riemann sum is either an over or under approximation. It's not the exact value. However, and I repeat however, it can be proven that the limit at infinity of a Riemann sum is the exact area. So here's our other big definition we want to make sure we get written out. The integral from a to b of f of x is equal to the limit as n approaches infinity, the summation from k equals 1 to n of f of x sub k times delta x. So first question, of course, you're going to ask me is, do you have to memorize that? Yes, you do. So we're going to practice it a bunch today and obviously within the next couple weeks to make sure we get this down. So here's the first example we're going to tackle. Notice that I'm starting off my problem by writing my formula down. The definite integral from a to b of f of x equals the limit as n approaches infinity from k equals 1 to n, the summation of f of x sub k times delta x. So here's our question. Write the integral from 0 to 4 of 2x squared plus 3 dx as a limit. So I kind of work backwards because I think this piece is the easiest. The first thing I do is I find delta x. So if you look back in your notes, the formula for delta x is b minus a over n. So here's my a, here's my b, and n is n. So I would say my delta x is equal to 4 minus 0 over n. So my delta x is 4 over n. Fairly simple. So like I said, working backwards, the next piece I want is x sub k. Now if you look back in your notes, the very first thing we wrote down under Riemann sums, we wrote the formula for x sub k. Yes, you've got to memorize this. This is a plus k times delta x. A plus k times delta x. We just got to keep saying it to ourselves. Put it on a flashcard, a plus k times delta x. So my a value is 0, very nice. So I've got x sub k equals 0 plus k times delta x. And guess what? You just found delta x. So it's k times 4 over n. So if I clean that up, 0 is obviously 0, I get x sub k equals 4k over n. Alright, so far so good. Now all I found was x sub k. Now I need to evaluate f of x sub k. So that's my next step. What is f of x sub k? So I'm really asking what is f of 4k over n. Sorry for the squeaky pen. So I'm going to substitute my 4k over n into this function any place I see an x. So f of x sub k is equal to 2 times 4k over n squared plus 3. So I'm going to keep cleaning it up. That's 2 times 16k squared over n squared plus 3, which is really 32k squared over n squared plus 3. Oops. And that's equal to my f of x sub k. So I just pulled up the formula, so I have it in front of me. I know it's on your paper. So I'm going to say the integral from 0 to 4 of 2x squared plus 3, 2x squared plus 3 dx, is equal to the limit as n approaches infinity, summation from k equals 1, to n. And I just said f of n sub k, f of k sub, f of x sub k is equal to 32k squared over n squared plus 3 times 4 over n times my delta x. And that is what they're looking for. Now, as far as I've only seen this asked as a multiple choice question. Could this be cleaned up further? Well, of course it could. Obviously, I could clean up my math a little further, and I could actually evaluate this limit. But as of today, we're just going to practice writing the limit out. All right, so let's try another example. The definite integral from 2 to 5 of 8x minus x squared dx. And again, I have my little cheat sheet in the corner here. So I'm going to work backwards. So the first thing I need to find is delta x. And typically what I've noticed is that usually narrows half the choices down. I'm just getting the correct delta x. So remember, that formula is simple. That's just b minus a over n. My b is 5. My a is 2 over n. So I would say my delta x is 3 over n. And that's fairly simple to get. Now I've got to remember that x sub k formula. Remember, that's a plus k times delta x. So my a value in this case is 2 plus k times 3 over n. And again, that's fairly easy to get. The next thing I have to get is f of x sub k. So I have to substitute all of this into every letter x I see. So in this case, it's a little more complicated because there's 2 x's, unlike the previous question where we only had 1 x. So my f of x sub k is equal to 8 times 2 plus 3k over n minus 2 plus 3k over n squared. Now again, if this is multiple choice, I'm just going to start looking for the right answer. I may need to clean it up more, I may not. So I am going to write this out as the limit as n approaches infinity, summation from k equals 1 to n. So this is my f of x sub k. So time of 8 times 2 plus 3k over n minus 2 plus 3k over n squared times my delta x, so times 3 over n. And there you go, I have my limit. All right, in the next example, it says write the following summation as a definite integral. So we're going backwards. We have to come up with the integral knowing the summation. So I basically said to myself, okay, given this rule, oh shucks, I probably should have the limit as x approaches infinity here. This is equal to the integral from a to b of f of x dx, and that was just that general rule we wrote down in the beginning. Okay, so now I kind of put it into my own lingo again. The limit as x approaches infinity from k equals 1 to n of f of, and remember what this value is, it's a plus k times delta x has to equal the integral from a to b of f of x dx. So hopefully I didn't scare you with this step. This is just the general rule. We find that a plus k times delta x, and we substitute it into f. So my next goal is to kind of compare what's in here to this a plus k delta x. So as I compare, it looks like perhaps my a value might equal 5. And notice I have a k times my delta x. So I'm going to assume my delta x equals 3 over n. So let's see if that makes sense. Don't forget I need a delta x outside here, and I'm assuming my delta x is 3 over n, and I also have it out there. So I think we're correct in making this match to this term. Now again, remember you're plugging this into function f, so the question now is who is function f? Who did you plug in this a plus k delta x to? Well, I think I just plugged it into the sine of x. Right, the sine of this junk, and that's where I plugged this into. So I think I'm about to put this all together. I would say this is the integral from a to b. My a is 5. I don't know my b, so I'm going to leave it as b. Of sine of x dx. Now I can easily figure out that b value because I know that my delta x is equal to b minus a over n. And I know my delta x is 3 over n, and b minus 5 has to equal n. So can you do a little mental math? If I kill those and add the 5 over, I know that b has to equal 8. So I would say my definite integral here is the integral from 5 to 8 of sine of x dx. Well, just as you suspected, we're going to get a lot more practice with this in class tomorrow. So I look forward to seeing you then, and have a great night.